Hello students, this is basically a microcontroller kit. Okay, this is the hardware that we will be using for the laboratory here. All these days, whatever the experiments we were doing, the simulator was mocking the behavior of this entire kit. So microcontroller as itself, it is not a standalone system. It requires other peripherals to work. So you can treat this as one interface embedded system. So whenever I say microcontroller, if you just recall, whenever I am typing a program, creating a project, we were selecting the target device. That is a type of the IC, okay, AT89C5 1ED2 from Atmel. So what we had selected there, the same IC we are using here. But in theory, we have studied that this IC is available in the dual inline package, that is pins on two sides of an IC. For to reduce the silicon area, okay, to reduce the size of the microcontroller, instead of dip pack, we have bought a quad pack. That means the pins are on all four sides of the microcontroller. So you can see we have a converter quad to dip. The kit was made for dip. The IC what we have a quad. So you can see the connections. Okay. Next, for this microcontroller, we know whenever I want to do the serial communication, I have RS232 cable. That cable's working voltage levels and its working is different than TTL logic. This is built on a TTL logic. So to match of the RS232 and TTL logic, we basically have a line driver, that is MAX232 IC. So this also we have studied in detail in the theory part. So we have the line converter. And we know there are 4 ports for the microcontrollers, each port of 8 pins. So we have port 0, port 1, port 2 and port 3. Since these are separate hardwares, they require their separate VCC and ground. So 8 plus 2, each of them will have 10 such pins. Now whatever the microcontroller is been doing, you can display the same on the LCD also using the LCD interface program. This is the LCD which can display its working. So whenever a microcontroller has to be powered up, we know it works on the voltage of 5 volts. So this is called as a power jack. Okay, from the adapter, okay, we'll actually connect it to the mains. We will have an adapter which will step down and convert the voltage to DC. So 230 volts AC to 12 volts DC or 5 volts DC depending on the requirement. Now for this I'll require 5 volts. So we from the adapter will connect it to the 5 volts and ground and put it to the power jack here. So this is basically the adapter you people can see. One end is going to the mains, the other end you can see ground and 5 volts. So this is basically called as a power jack. We will have to connect it here. Once power is on, you can see the LED will glow indicating the complete path for the power supply. So this is the default connection. This is must for any interfacing. Next, whatever program we type, we will be typing the program in the computers. We all know that. Okay, we have seen, we have simulated many experiments. Now once I have ensured the simulated program is working fine, the program has to be then dumped to the hardware, right? So whatever the program is there on the CPU should be transferred here. How is it transferred? It has to be transferred through a serial cable. This also we people have studied, RS232. One end is going to the COM port of the computer. The other end is just like your telephone cable, RJ11 cable. So this is called as RS232 cable, serial cable. You can see a serial jack here, just like your telephones and LAN wires. You will have a notch, you will have to adjust it and insert. Once you insert, you will get a sound indicating it is been completely established, the connection is completely established. So these two, power and RS232, are the compulsory connection for the microcontroller. Now we have made connection as an input to microcontroller. Suppose I have written a program, tested. Now that has to be sent to the microcontroller through RS232. We'll see the process later. Suppose the program is sent here. What should I be doing? I should be controlling some target, right? It can be a DC motor, stepper motor, or a temperature sensor. Any target device has to be connected to this. So how do we connect? We have different options here. Okay, so port 0, port 1, port 2, port 3. You can use any of this. These are called dedicated ports. Okay. instead of using all these three, we have an integrated port here. Okay, 26 pin integrated port. Okay, flat ribbon cable port. Okay, so it can be used as port 0 or 1, 2 or 3 depending on our program. Our program decide how this basically acts. So at one point of time, one FRC you can use it to interface 2 port to be integrated. So we will be connecting an FRC to this. An example for an FRC is this. Okay, flat ribbon cable. All the channels are all the wires are converted into a bus. Same 26. Female jack is there. We have a male jack. You will have to connect it. So this completes the interface to the microcontroller. How do we basically connect? You can see a groove here in the kit. Okay, the same way you can see a notch here on the FRC. You have to match both the groove and notch and press it. Once you press, you can see these get locked. Okay, this is the connection you will have to make for the microcontroller.